digits, decimal point to the right. 1, 2, 3, 4, 5, 6. Those blank filled in zeros. So it's $12,200,000. Question 10. Question 10 is started with this, is going to be the chapter 2 questions. Chapter 2. Started with limit. Limit. Figure out the limit when x approach to 1. This polynomial, degree 2 polynomial, quadratic polynomial. First of all, you can factor it, because approach to 1 is not approach to infinite. If approach to infinite, you can use the quick way to do, like this. If approach to infinite, you just do 2 over 2, and answer is 1. And its degree is equal. Just divide leading coefficient, get 2 over 2, get 1. And that's a quick way to do. And since this is not approach to infinite, it's approach to 1. Approach to 1, if you plug it into the denominator, you will get 0. And if you put in numerator, you will get 4. 4 over 0. 4, this approach to 0 become very, very small. Become very, very small. And the 4 numerator constant on the top divided by very small is approach to infinite. You can do this. You can directly plug in 2. 1 plug in 2, add 5, minus 3 is 4. And plug 1 in denominator, 2 minus 3, add 1 is 0. Divided is infinite. And this one, since you can factor it, so factor it, and cancel common factor. Factor canceled, get x plus 3 over x minus 1. Then you plug in and still get 4. And 1 plug in, still get 0. And 4 over 0 is infinite. And how to factor this? How to factor 2x squared plus 5x minus 3. How to factor? First of all, 2. 2 is 2 times 1. Cross multiplication, negative 3. Negative 3, you can put negative 3 times 1. If you cross multiplication, this negative 3, this is 2. Add together equal negative 1. It's not external coefficient positive 5, so this is not right. But you can switch it. 2, 1, negative 3, 1. This exchange. And you cross multiplication, 2 times negative 3 is negative 6. 1 times 1 is 1. Add together is negative 5. But we want positive 5. So I just move this to negative, this to positive. And negative times 3 is still negative 3. 2 times 1 is still 2. 2 factor as 2 times 1. Negative 3 factor as negative 1 times 3. If you times it, become 2 times 3 is positive 6. Negative 1 times 1 is negative 1. Add together is a positive 5. Positive 5 is a fit this external coefficient. So this is the right one. Right one, then you put the x. Put x because this 2 times 1 is come from x squared term. Separate x squared term to each one. Put the parentheses. And the factor is 2x. So this factor equals 2x minus 1 times x plus 3 factor. And you can check it. 2x times x is 2x squared. 2x times 3 is 6x minus 1x and got positive 5x. Last term product, negative 3. It's checked. That's question 10. Next one, 10A. 10B, also limit question. 10B, also limit question. This time is go to infinite. go to infinite. There's a shortcut way to do. I'll tell you shortcut way later. Now let's do long way first, because that tell you the reason why. So first of all, you divide each term by x squared. 2x squared divided by x squared get 2. 3x divided by x squared cancel x, gets 3 over x, plus 1 divided by x squared got 1 over x squared. Then x to the power 4 divided by x squared cancel 2, 4 minus 2. Oh, you didn't see it, so I'll repeat. Now, first of all, each term divided by x squared. 2x squared divided by x squared, cancel x squared, get 2. 3x divided by x squared, cancel x, get 3 over x, plus 1 over x squared divided by x squared. Then x to the power 4 divided by x. 4 minus 2 is 2, so get x squared. X squared divided by x squared, get 1. So each term divided by x squared, simplify, get this. Now, then, when x go very, very big, very, very large to infinite, 3 over very large approach to 0. 1 over very large approach to 0. So this 2 become 2 add 0, add 0. X squared still infinite, minus 1. Infinite square still infinite, minus 1 still infinite. 2 over infinite, denominator become very, very big. 2 over very, very large number become very, very small, approach to 0. So this limit is 0. This limit is 0. So that's the reason. Now there's a shortcut way. If numerator denominator 2, if less than denominator degree of numerator 2 is less than denominator degree. That means when x go infinite, this to the power 4, the infinite to the power 4 infinite is become very, very go to infinite, become compare with numerator. Its denominator is very, very large, greater than the numerator, become faster to infinite than the numerator. So therefore, numerator is compared with denominator. Numerator is small and denominator is large. After divided, is approach to 0. Become smaller, 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 and approach to 0 because denominator x to the power 4, numerator x squared, denominator go infinite, become larger and larger and larger. So the number you divided by very, very large number become very, very small. So limit is approach to 0. So first of all, if limit p of x over q of x, x go infinite, if a degree of numerator p of x is less than degree of numerator or of denominator degree, then limit is 0. That's a quick way to do, just like this example. Because denominator degree is higher, so go to infinite much faster than the numerator. So after divided become very small, approach to 0. Now then C, this one limit when x approach to infinite. Now the two have the same degree. The shortcut way is just leading coefficient divided. 4 over 6 reduce is 2/3. It's a 4 over 6, 2/3. Now tell you the reason. Here tell you the why. So because it is x cubed. So you each term divided by x cubed. 4x cubed divided by x cubed cancel, get 4. X squared divided by x cubed, cancel x squared. Remain 1x on denominator, find 1 over x, and plus 1 divided by x cubed. 6x cubed divided by x cubed, cancel, get 6, and plus 1 over x cubed. Now, then, when x go infinite, 1 over infinite, 1 over big number, approach to 0. 1 over x cubed, infinite cube, very, very big. 1 over very, very big, become very, very small, approach to 0. 1 over also approach to 0. So it's got equal 4 plus 0 plus 0 over 6 plus 0 is 4 over 6. Reduce, cancel common factor 2, get 4 over 3. So if they have the same degree, when x approach to infinite, you just do leading coefficient divided 4 over 6, 2 over 3. So that is the quick way to do. So formula is over here. If limit x approach to infinite, if a degree of numerator equal degree of denominator q of x, then the answer will be leading coefficient of numerator over leading, LC means leading coefficient of denominator. What is the degree? The highest exponent on this have 3 terms. First term degree is 3, second term degree is 2. The constant term degree is 0 because x to the power 0 is 1. So highest exponent is 3. So this polynomial degree is 3. And the highest exponent term coefficient, those 4, this 1 we call coefficient. The highest exponent coefficient we call leading coefficient. So this polynomial leading coefficient is 4, degree is 3. And this polynomial, there's 2 terms. One term degree is 3, second term degree is 0 because x to the power 0 is 1. 1 times 1 is 1. And so degree of polynomial is highest exponent. 3 is the degree of this polynomial. Leading coefficient is the highest exponent coefficient. This term with highest exponent 3. That term's coefficient we call leading coefficient. So the 2 leading coefficient divided is the limit. Now D also, the numerator is also x approach to negative infinite. Here's approach to negative infinite. The numerator degree is higher than denominator. Then that means when approach to negative infinite, this numerator go faster than the denominator because the degree is higher. So it's go infinite faster than the, so numerator become very, very large compared with denominator. Divided is still very, very large. So answer is infinite. Positive or negative, you can figure out. So you do first of all, you divide each term by x cubed. X to the power 4 divided by x cubed. 4 minus 3 is x to the power 1. And minus 1 over x cubed. And x cubed over x cubed is 1. Minus 1 over x cubed. And limit x go to negative infinite. So when x go to negative infinite, this x is a negative infinite. Minus 1 over x cubed. X cubed is a negative infinite because negative infinite cube is still negative. Negative times negative become positive. 1 over infinite is 0. 1 over big number is 0. So this side is 0. This also 1 minus 1 over this side is negative infinite because negative infinite cube is still very, very big but negative. 1 divided become very, very small, but change the sign, become approach to 0, become 0. So you add together. So answer is negative infinite. And the next question is approach to infinite. D is approach to negative infinite. E is approach to positive infinite. Numerator degree is 2. Denominator is degree is 1. Then that answer will be infinite. Positive or negative? you divide each term by x. So 7x squared divided by x, cancel x, gets 7x. And 3x divided by x cancel, gets 3. 2x over x cancel, get 2. Minus 1 over x. So when x approach to infinite, 7 times infinite minus 3, 2 minus 1 over infinite is approach to 0. Then 7 times infinite, still infinite, minus 3, still infinite. 2 minus 0 is 2. Infinite divided by 2 is still infinite. So this answer is a positive infinite. So from here, you can get conclusion. If the degree of the numerator is greater than degree of the denominator, when x approach to infinite, answer is infinite. So the three case. Now next one, f, limit this h approach to 0. If you plug it into h use 0, you got 0 over 0 because h is 0. This is 4. Take square root is 2. 2 minus 2 is 0. So numerator, denominator, both are 0. 0 over 0 is not equal 1. 0 over 0, you can be 1 because 1 times 0 is 0. You can be 2 because 2 times 0 is still 0. 6 divided by 2 equals 3 because 2 times 3 equals 6. 6 divided by 3 equals 2 because 3 times 2 equals 6. So division is come from the multiplication fact. And why 6 divided by 2 equals 3? Because 2 times 3 is 6. And why 6 divided by 3 equals 2? Because 2 times 3 is 6. That's come from multiplication fact. So 0 divided by 0 is a number, and that number times 0 should go back to 0. And 1 times 0 is 0. 2 times 0 also 0. And you can be 3 because 3 times 0 also 0. So 3 times 3 is equal 1. It can be 2, can be 3, can be any numbers. So 3 divided by 3, the answer is indeterminate. You can be any number because any number times 0 go back to 0. Answer is indeterminate. Now, how about 2 divided by 0? Can be a number. A number times 0 go back to 2. What's number times 0 go back to 2? No such number because any number by multiplication fact, any number times 0 is always 0, never go back to 2. So this one, no answer, undefined. So any non-zero number divided by 0, if a is non-zero, answer is undefined. Any non-zero number divided by 0 is undefined. 0 divided by 0 is indeterminate. Now how about 0 divided by 2? Certainly 0 because 0 times 2 equal go back to 0. 0 times 2 is 0. So any 0 divided by a is non-zero number, answer is 0. So 3 case. So 3 case. One is 0 divided by a is 0, where a is non-zero. The other one is a divided by 0 is undefined. There's no answer. Here a is non-zero. And the third case is 0 divided by 0. Can be any number and then we don't know which one. So we say indeterminate. Indeterminate. 3 case. Indeterminate. So like this question, if you do h plug in, you will get 0. And then numerator is 0. Denominator h plug in, you got 4. Take square root is 2. 2 minus 2 is also 0. It's 0 over 0. And what's the limit? You don't know. Because 0 divided by 0 can be any number. Indeterminate. So then how to decide what's the limit? So we can change it. So this h numerator times by denominator conjugate. Here's minus, conjugate is plus. The two we call conjugate to each other, minus and the plus. The two factors are conjugate to each other. So both sides times by this denominator's conjugate by this. You can cancel this, is still original. So both numerator denominator times by this factor by denominator's conjugate, which is minus changed to plus, is conjugate. And both sides times it. Now you multiply. Numerator is still this one, copy done. Denominator use formula a minus b times a plus b equal a squared, this square. A is the square root of 4 plus h square minus b squared 2 square. Or you can use FOIL. This time this is square. This outer term product, inner term product combined is 0. Then last term product is negative 2 square. Then figure out the numerator still copy down. Denominator square. Square root square cancel. Get 4 plus h minus 2 square is 4. 4 minus 4, 0. So remain h. And this h cancel with the numerator h. Cancel. So become limit h approach to 0. Square root of 4 plus h plus 2. And put the parenthesis. And 0 plug in h. Got 4 plus 0, which is 4. 4 take square root is 2. 2 plus 2 is 4. So answer is 4. So this question limit is 4. You just modify it, then you can get the answer. The next question, question 11. Question 11. Given a function f of x equals, this we call piecewise function. 3 piece. When x is less than -1, use function -x plus 1. If x is between -1 and 1, including -1 and 1, greater than or equal -1 and less than or equal 1, use is 2. If x greater than 1, use this -x plus 2. And function, piecewise function, ask for limit. And you can use the graph. You can draw the graph to help you. If you don't draw graph, is okay, but you can use the graph to help you to understand better. And how to draw the and to check to make sure your answer is correct. So this is the function. This one is the function. Now I'm going to draw x-axis and the y-axis. Draw x-axis and the y-axis. And here is x, here's y. And here is a -1. And here it's 1. Now, -1, less than -1, like -2, -2. And you plug in. -2 times negative is 2. 2 add 1 is 3. So it's 3. 1, 2, 3. So when -2 is 3. Now, -1, you temporarily put in here will be 2. -1 will be 2. So when x equal -1 is 2. But since when x equal -1 is not defined on here, is defined on here, is 2. When x equal -1 is 2. So for the first one, -x plus 1, x has to be less than -1, not including -1. So I put a open circle here. This point with this point connect. This is the straight line for the first one. This is a -x plus 1. Y equal -x plus 1. Then from -1 to 1 will be 2. Always 2. Always 2. So from -1 to 1 is always 2, including the two endpoints. Including -1 and the 1 is always 2. So its graph is go like this, 2, horizontal line. From greater than 1, if a 1 plugged in here is -1 plus 2, started at 1. -1 plus 2 is 1. So when x equal 1, started at 1, but open circle because it's not defined by 1, it's defined by 2. And then you go to the right, 2. -2 plus 2 is 0. It's here, 0. Then you got this. So this line is -x plus 2, y equal. And this line is y equal 2. And this line is y equal, this is the first one, y equal -x plus 1. And this is y equal 2. And this line is y equal -x plus 2 and 3. Got 3 parts. You can see from here. Now let's do questions. A. Limit x approach to -1 plus, which is approach to -1 from right side. Which is x approach to -1 plus, which is right side. Approach to -1 from right side. Which is when x approach to -1 from right side, that means here x has to be greater than -1. X approach to -1 from right side, those x is greater than -1. So you have to plug into x greater than -1, which is this one. This is x less than -1. This is x greater than -1. The function is 2. F of x equal 2. So that limit is just 2. Then limit x approach to -1 from negative side, from left-hand side. So which is x approach to -1 from negative side, from left-hand side. So it's x approach to -1 from left-hand side. Those x has to be less than -1. X has to be less than -1. X less than -1, which is the first one. When x less than -1, then when x approach to -1, you plug in. Negative times -1 is positive 1. Add 1 is approach to 2. So limit is 2. Limit is 2. You can see from the graph. When x approach to -1 from positive side, from right-hand side, the limit is approach to 2. Y is approach to 2. Because this point is -1, 2. And y is approach to 2. And when x approach to -1 from left-hand side, the function value y is also approach to 2. Also 2. So this is 2. And since they are equal, so when limit x approach to -1 from right-hand side plus side, f of x function value approach to 2. So limit is 2. Equal to limit x approach to -1 from left-hand side. Function approach to 2 also. Function value also 2. Limit also 2. Since the two limit are equal from left-hand side, from right-hand side, the same limit equal 2. Then you can say limit x approach to -1 equal 2. So limit when x approach to -1, the y is approach to 2. Function value approach to 2. So put it in general. This is general. Limit x approach to a from positive side, from right hand side, f of x function value is approach to L, limit is L. If equal to limit when x approach to A from left hand side, negative, left hand side, the function limit is also L. If from left hand side, from right hand side, when x approach to A from left hand side or right hand side, the function is limit is the same, equal, function approach to the same number, then you can say the limit when x approach to A, f of x approach to L. Limit is L, is the same as this. If they are equal from left hand side and from right hand side, if limit is equal, then you can say limit at that point, x approach to that point, the function is also approach to the same limit. So this is you can say the limit when x approach to -1 is also 2. Then next, ask you whether f is continuous at x equal -1 or not. And how to determine it's continuous or not. Here is the formula. If the limit x approach to A f of x equal f of A, then you say f is continuous at x equal A. If it equal f of A, so like this question, what is the f of -1? F of -1, x equal -1, f of x is -1 is 2. So f of -1 is 2. So for this question, when x approach to -1, f of x equal 2, and that is equal f of -1. So it's when x approach to A, f of x is -1, f of x equal to f of -1 equal 2. So it satisfies this. So then you say f is continuous at x equal -1. Yes, it is continuous. So there's the two theory. One is to determine whether if that limit L is the same as f of A, then it is continuous. Then next question is going to be if x approach to positive 1. Here, x approach to 1 from positive side, from right hand side, which is x greater than 1. So x greater than 1, you plug it in here. Then y value, function value, -1 plus 1 plus 2. -1 plus 2 is 1. So limit is 1. Limit is 1. When x approach to 1 from right hand side, which is x greater than 1, so you plug it into this, x greater than 1, and use 1 plug it in. The limit is approach to -1 plus 2, which is approach to 1. So limit is 1. When x approach to 1 from negative side, which is from left hand side, so it's x less than 1. X less than 1, you will use this function, x less than 1, which the function is always equal to, always constant. So limit is always 2. So this one, when x approach to 1 from right hand side, limit is 1. When x approach to 1 from left hand side is 2. They are not equal. So if you look at the graph, x approach to 1 from right hand side, the y value is approach to 1. X approach to 1 from left hand side, from negative, 1 negative, which is from left hand side, the y value approach to 2. Approach to 2 is this graph, approach to 2. So they are not equal. They are not equal. So you can say limit at 1, when x approach to 1, the function limit There's no limit. Doesn't exist. So limit x approach to 1 f of x doesn't exist. Do not exist. Do not exist. Does not exist. DNE. There's no limit. And then ask you, is f continuous at x equal 1? If not exist, then this will not satisfy, because limit x approach to 1 f of x do not exist. And the f of 1 equal 2. They are not equal. It's not equal. So it's not continuous. And you can look at the graph. This is not continuous. This have a jump, a gap. It's not continuous. At this point, it's continuous because it's continue. At this point, you cannot continue. You can use the graph to check it. And so question 12. Question 12. A manufacturer has a monthly fixed cost of $40,000. Fixed cost is $40,000. Monthly fixed cost, for example, a mortgage, pay mortgage, or pay a rental fee. And that's a fixed cost, $40,000. And a production cost for each unit produced, each unit cost is $8. If produce X units, so totally cost for month. If 1 month produce X units, 8 times X plus $40,000, that's the cost function. Total cost function is a production cost. Each unit is X, $8 times X units per month. Produce X units plus fixed cost, $40,000. That's cost function. Revenue is each unit. If you sell the product sales for $12 per unit, and if total sell X units, so revenue is money, income is 12 times X. Profit is income minus expense minus the cost. So profit function is equal revenue minus cost. So this minus this, and you need to put the parentheses. Revenue is 12x. Cost is put the parentheses. Remove the parentheses. Negative times positive is a negative. You need to change the sign. Combine like term. 12x minus 8x is a 4x. So it's a 4x minus 40,000. That's profit function. Then D. Compute the profit. Is loss. Profit means you have a net income. Net income. Loss means negative. Corresponding to the production level is 8,000 units or 12,000 units. Now 8,000 units is X, and X you plug in. Profit put into the profit function. 8,000 plug in. And then put in here 4 times 8,000, get 32,000 minus 40,000. Subtraction is a negative 8,000. So this is a loss of $8,000. And you do 12,000 units, plug into X. P of 12,000, 4 times 12,000 minus 40,000. So get 48,000 minus 40,000, get 8,000. Positive. So profit of $8,000. So that's number 12. And